Hello, this is Mrs. Huntley. This is Module 4, Lesson 7, Classification of Solutions. You should be on page 49 of your student workbook. Your EQ for this lesson, what are the different classifications for the solutions of linear equations? Okay, so right off the bat, I'm going to ask you to pause the video and work the three problems on page 49. Use whichever strategies are helpful to you to keep it straight. If you're looking at the first problem, first look at the left side and the right side of the equation. On the left side, there's nothing that you can simplify anymore. Same thing on the right side. So the left side expression and the right side expression are already simplified. You just have to start using your addition and subtraction properties of equality to get the variables all to one side, the constants all to the other side, and then the variable isolated. So go ahead and pause the video, solve those three equations, and let's see what happens when we come back together. Okay, again, I hope you did pause the recording, and I hope that you worked on these on your own. I'm going to work through them right now, and you can check your work as we go. So with this first one, let's see, I need to get all of the variables to one side. So I'm going to subtract 5x, subtract 5x. When I do that, I'm left with 2x minus 3 equals 5. Then I'm going to add 3, add 3. I've got 2x equals 8. Divide by 2, divide by 2. I have x equals 4. The next equation. You know what, I should actually take that 4. Let's go ahead and check it and make sure I did that right. So 7 times 4 minus 3 equals 5 times 4 plus 5. 7 times 4 is 28 minus 3 is going to be 25. 5 times 4 is 20 plus 5 is 25. So I know my solution is good. Okay, the next one, let's see, I've got 7x minus 3. That's as simple as it gets. 7x plus 5, that's as simple as it gets. I'm going to move all my variable terms to one side. And I end up with negative 3 equals 5. Does negative 3 equal 5? No, negative 3 does not equal 5. We learned last lesson that we call this a no solution. So let's see what happens with the next one. Again, the left side and the right side are as simple as they get. Let's move our negative 7x, and I end up with negative 3 equals negative 3. Okay, does negative 3 equal negative 3? Yes, it does. So this one is not like number 2. This one we say has all real numbers. Any number that I plug in for x is going to make the equation true. So we say that there are infinitely many solutions to the equation. So our first example, there's one solution and only one solution. Our second example, there were no solutions. There was no number whatsoever that were going to make this true. We learned that again last lesson and this lesson. So the new one that we're adding to the mix is when our variable term drops out, meaning that they zero out on both sides of the equation, and you're left with a statement that's true, like negative 3 does equal negative 3. So it does not matter what value of x I plug into this equation, it's going to make the equation true. Let's go ahead and turn the page. So if we're looking at problem number 1, that's the one that we solved, and the problem worked out as expected. The coefficients are different. That's our number that's being multiplied by x on both sides of the equation. 7 is different from 5. So when I subtract out the 5x from both sides, I have an x term that's still left, and I can solve. What this means is there is one and only one number that's going to make the equation true. The next kind of problem that we solved, the number 2, 7x minus 3 equals 7x plus 5. Our coefficients are the same. 7 is the same as 7. So the constant terms here, the ones that don't have any variables with them, are different. That means our variable terms are going to drop out of the equation, and we'll be left with a statement that's not true, and there are no numbers that will make the equation true. There are no solutions. The final one that we looked at, the coefficients, again, are the same. 7x is equal to 7x. The constant terms are also the same, negative 3 negative 3. So all real numbers will make the equation true, and there are infinitely many solutions to that equation. The activity down below, take a look at these equations and see if just by looking at them you can decide if there's going to be one solution, no solution, or infinitely many solutions. I'll do the first one with you. So looking at this first equation, 3x plus 4 equals 8x minus 9. Our coefficients, 3x and 8x, are different. So we're going to expect that one to have one solution. So I'm just going to write a little 1 next to it right here, so I remember that I did that one. The next one, 6x plus 5 equals 8x plus 6. Our coefficients, 6, are the same on both sides of the equation, but our constant terms are not the same. 5 and 8 are not equal. So I would expect this one to have no solution. Final column, I've got 10x minus 4 equals negative 4 plus 10x. So again, my coefficient 10 and 10 are the same. My constant terms, negative 4 and negative 4, are also the same. So this one, I'm going to say infinitely many, or I'm just going to use a little infinity sign like that. So go ahead and go through the next grouping. Negative 4x minus 5 equals 6 minus 11x. Indicate whether you think there's going to be one solution, no solution, or infinitely many solutions. Just write maybe a little something next to them and see if you can classify the rest of these equations. Go ahead and pause the video and do that. Okay, hopefully you did go ahead and pause the video and you notice that all of these grouped in this first area here are coefficient. We've got negative 4 and negative 11. Those are different, so I'm going to expect one solution here. The next one down, I've got my coefficient here on the left side is 1/2, on the right side is 5. So again, all of these I'm going to expect to have one solution. This middle column, again, if I'm looking at my coefficients, they're the same. If I'm looking at my constants, they are not the same. Same thing here, coefficients are the same. Constants, negative 1, positive 1, not the same. So here we're going to say no solution. The last one, I'm looking at negative 2x, those are the same. 5, 5, those are the same. 9, 9, those are the same. 7, positive 7, those are the same. So again, I would expect all real numbers to be able to satisfy this equation, which means there are infinitely many solutions. Putting this in words for your notes. In equations where both sides of the equal sign are simplified and the coefficients of x are unique, meaning they are different from each other, and the constants are unique, meaning they are different from each other, there will be one solution. 2, when the coefficients of x are the same but the constants are different, there will be no solutions. And finally, when the coefficients of x are the same and the constants are the same, there will be infinitely many solutions to the equation. Go ahead and pause the video. We are going to do some on your own problems. I would like you to do all of the on your own problems on page 51, and then go ahead and unpause the video and see how you did with them. Okay, so with the first one, the first thing we want to do on the left side of that equal sign, we want to combine some like terms. So I've got 11x, I've got negative 2x. So that's going to be 9x plus 15 equals, let's look at the right side, I've got some like terms there too. Change colors. Eight plus 7 is going to be 15 plus 9x. So I am looking at this problem and I have my coefficients are the same and my constants are the same. So that means there are going to be infinitely many solutions. All real numbers will satisfy this equation. The next one, again, I need to attack the left side and the right side of the equation. So the first thing I'm going to do, I see parentheses. I'm going to distribute that 3 to everything inside the parentheses. So I've got 3x minus 3 times 14 is 42 plus 1. Is that equal to negative 4x plus 5? Okay, right here, oh, actually, I can simplify that a little bit more. 3x, negative 42 plus 1 is going to be negative 41 equals 4x plus 5. Okay, right here, both sides of my equal sign are simplified, and I can see that my coefficient of negative 4 and 3 are different numbers. So I'm going to expect this one to work out to have one solution. So let me go ahead and continue solving it. So I'm going to add 4x to both sides of the equation. 7x minus 41 equals 5. Add 41. 7x equals 46. Divide by 7, divide by 7, and x will equal 46 sevenths, or 6 4/7. I can take that number, plug it back in, make sure that it works. Okay, that solution's kind of a weird solution, but I did go ahead and plug it back into the original equation, and it's a little bit ugly, but the left side of the equation ends up being negative 21.28571429, as does the right side of the equation. So trust me that that is a good solution. And it is one solution. Actually, I could have stopped right here where I'm looking at negative 4 and 3, because actually they're just asking us if there was how many solutions that we would expect. But honestly, I would expect you to take it all the way through. Looking at the third one, same thing. I need to simplify both sides of the equation before I can determine anything. I've got negative 3x. I've got negative 7x. That's going to be negative 10x plus 32. I need to distribute. Negative 2 times 5 is negative 10x. Negative 2 times 10 is going to be negative 20. Coefficients are the same. Constants are not the same. Therefore, I would expect this one to have no solution. Okay. Quick and easy today. So that is the end of the video for lesson 7. I will see you in class tomorrow.